Who got you on?
Okay. Hi everyone, I'm Olivia, and this is my presentation on grass and grazers. So just as a heads up before I begin though, I may use the terms grasslands, prairies, and pastures a bit interchangeably, so just a warning. So first of all, what is a grazer? A grazer is any kind of animal that feeds itself primarily on grown grasses and herbage. Grasses and grazers have a long coevolutionary history, which in many cases makes them interdependent, and in more extreme conditions, renders the two species inseparable even. Grazing puts selection pressure on grass, which affects its processes from nutrient uptake to photosynthesis. But their mutual relationship is very delicate, and miniature upsets such as overgrazing can prove harmful to their balance. From my research, the net outcome of grazing on grassland health is unclear. Certain species of grass appear to benefit from grazing, from elements of grazing and not others, while some species of grass benefit by the process of grazing, by removing competition, but not by being grazed themselves. But grazing is undeniably a major process in grassland environments. So, research. Well, it took me a lot of research for me to create a specific hypothesis and essential question. I started off by considering the primary interactions of grasslands, grazing. This was a good start, a relatively simple interaction between a plant and animal, which is connected to the plant's photosynthetic properties and thus carbon emissions, a good connection to human life. So my EQ started out with a very general question. What is the relationship between grass and grazers? I then worked to narrow this down to a point of ongoing debate within the scientific community. After more research than I anticipated, I landed on grass phenotypes and their relationships to grazing. Before I spoil any more of my EQ though, I asked, how do the physical structures of grass differentiate when exposed to the selective pressures of grazing? How do mutualism and coevolution reflect in the observable traits of grass? Well, before we continue, here are some connections. First, starting off with chemistry, the strongest link that grazing has to chemistry is its effect on the soil around grass. Specifically, grazing intensity is a determining factor on the chemical composition of soil around grass. Under or overgrazing can make soil non-optimal for grass development. Grazing also affects chemical processes of plants such as photosynthesis and affects soil respiration in the soil. Several experiments note that non-optimal grazing conditions lower plant photosynthetic rates while raising soil respiration rates. This allows more carbon to escape into the atmosphere and is actually bad for carbon emissions. The strongest link that grazing has to physics is soil degradation. Soil degradation usually happens because of compaction, when the weight from roaming plants packs soil particles together more densely than it would be naturally. When soil is too compacted, it is less permeable by gases, water, and plant roots, and is less supportive of microorganism activity. Compaction also reduces pore space in soil, further restricting grass root growth and more general biological activity, which is necessary for healthy soil. So, going to my methods, I had two major parts of my experiment: collecting data and analyzing data. For context to my data collection, these are two pastures here, which are separated by a freeway. Historically, these evolved as one, but less than 100 years ago, this freeway separated both sides of the pasture. And as of at least 10 years ago, grazing horses were introduced to only this side of the freeway. I took samples of grass from each side of the freeway with 30 by 30 centimeter perimeters and depth of 20 centimeters. For each grass sample, I measured its average above ground length, average density, and average phenotype diversity. To measure the above ground length, I selected 5 grass organisms at random, held a ruler from the plant's tip to where it touched the soil, then recorded its length in centimeters. To measure grass density, I carefully separated 5 by 1 centimeter plots of grass from my 2 samples and counted how many grass organisms were in each plot. I divided this number by 5 to find organism density per centimeter. Lastly, to measure phenotype diversity is more complicated. Using 10 by 10 centimeter subplots of grass, I wrote down my observations of the phenotypes of each plant that I was able to identify. I then recorded each plant by its most apparent phenotype and researched that phenotype to confirm its legitimacy. Once I'd recorded a list of phenotypes and the frequencies, I used the Simpson's index to calculate their precise diversity. So, what I found out about my central question through my experiment was how the selection that's put on grass by grazers was exemplified by differences in traits of grass from grazed and ungrazed pastures. Grazing is such an essential selecting force on grass because it causes both directional and stabilizing evolution on grass. The directional evolution being shorter stature, shorter blades and cone length, and the stabilizing selection being on its diversity. What makes it even more important, particularly for the directional selection, is that without grazing as a factor in the grass system, the grasses will naturally be selected for being taller and having more access to light. This has the potential to cause tons of complications regarding competition, but introducing grazing selects in the exact opposite direction, so over time there will be a new balance, and grasses will be evolved to be just short enough to protect themselves from grazing, but still tall enough to have sufficient access to sunlight. What I also found though, is that the density of grasses was higher in grazed pastures. I researched this, and this is the pattern amongst grazed grasses, but my research didn't specify why. So my theory is, like I touched on earlier, that there's more competition amongst grasses in ungrazed pastures because they're all working against each other for the most exposure to light. But grazing eliminates much of this competition. The grasses in grazed pastures do not have to compete against each other in the same manner because they're roughly the same height and therefore can all thrive together more easily. So I learned a lot from this experiment, which I think might have been the most ambitious science experiment I've carried out. I've learned a lot from having to replan the contents of my experiment because its final form was far from my original plans. I originally wanted to observe grass stems through microscopes, centering my research on those observations, but I designed the experiment without a pre-understanding of my end goal. Something I learned is a necessity for good science experiments. The process I sought to do in my final rendition of the experiment intimidated me at first, because it felt like it was too much, especially with such an elaborate data preparation phase, which is something that had usually been one of the more minor steps for me in the past. Because of my thorough end goal and good idea of everything I needed to do though, everything went smoothly and according to plan. If there's one word I learned from this experiment, that would be preparation. So, the relationship between grass and grazers is a strong example of mutualism, but it is one which exemplifies the fragility of ecosystems. And with just little interference, overgrazing, undergrazing, and carbon emissions are just a few of the serious impacts that human carelessness can have on the environment we depend on. But we can have even more impact if we're not careful. So, using my sources. I went a bit short, I cut it down a bit much, like 9 minutes. But yeah.